Right, guys. So what we're looking at here is the dehedral angle between two traces. Okay, so we can see here we've got two oblique planes. I have one here in red and one here in yellow. Right, and I just do a quick little sketch here. Look, so our vertical plane here, look, is in the blue. Horizontal plane is in the green. All right, we can see our VTH, and V1, T1, H1, V1, V1, T1, H1 here. All right, and you can see, look, that one plane is intersecting the other. Right. So you can see this yellow one here at the back. I just have a kind of a highlighter yellow there. So it's cutting through this oblique plane here. So this oblique plane, look, is going across this way, and this one's going across the other way, right? And they're meeting here in the middle, right? And you can see there, look, where they're meeting, lads, is called the line of intersection, okay? Now, why that's important is, lads, is because we're looking for what's called the dihedral angle. And the dihedral angle is basically the angle between the two planes, right? So where these two planes intersect, or where the two of them meet, so something like that. We're looking for the angle in between the two, like that. Right? So the angle in between there, we're looking for that. Right? Now, to find that, guys, right? If we want to find the dehedral angle, and if we want to find out where they intersect, right? What we do is we're going to join up our traces. Okay, and I'll show you how we do that here now. Okay. Now, the reason why we're doing that is because if we can find the line of intersection, okay, just like we kind of did early on in the year in auxiliary elevations, right? Okay. If we can find the line of intersection, and if we stand up here and look along it, we'll be able to see the angle in between the two of these. Okay? We'll see the two of these guys as a plane view, and we'll be able to see then our dihedral angle. Right? So if you notice here as well, look, where the two vertical traces, okay, where they intersect, and where the two horizontal traces intersect, if we join up the two of those, it gives us our line of intersection. Right? So we're going to do that there now, so, right? So the first thing we're going to do, so guys, right, is we're just going to join up our vertical traces in our elevation, just like that. All right, I'm going to do the same in plan view. All right, so we're joining up these guys. We're just extending them on, right? So you can see the way they're extended onto infinity, and we're just seeing where they intersect. So they're intersecting here and here, similarly here as well. All right. So what I'm going to do now, lads, I'm just going to bring that straight down, like so, like that. Just a little around that. All right, and I'm going to join it then to the intersection of this. Right, and I'm going to do the same then with this guy, and bring this one straight up. Just put it straight up, and then I'm going to join to the intersection there. All right. So basically, that's giving me there as its line of intersection. All right. So this is the line of intersection here in the elevation. This is my line of intersection here in the plan. Right. So if I folded those up, they kind of match up. All right. Now once you've got the line of intersection, lads, you're halfway there. Okay. Because what's that's giving you then, lads, right, is if we can look along that then. So if we can see that, if we look along that, we'll be able to find exactly there where it is where our dihedral angle will be. All right. So we're going to look at that there now next. So if we look along the line of intersection, this guy, or similarly this guy. So if we look along the true length of that line of intersection, we will get the true angle between the two planes, or the true angle, or another word for the true angle would be the dihedral angle between the two planes. But the first thing we have to do before we do that is we have to get the true length of this line of intersection. So it's going to write in there line of intersection. Intersection. Right here. So that's our line of intersection there, right? So to get the true length of it, okay, so again, going back to stuff we did earlier on, we're going to we're going to draw an auxiliary of that, all right? we're going to take our heights then from our elevation. Right, so I'm just going to bring that over like that. And again, look, I'm going 90 degrees to it. And drawing an XY line which is parallel to my line of intersection. Alright. So, sorry, my video is not there. So, if you look there, so just going back to what I was saying, so if we look along our line of intersection, okay, we'll be able to see the true angle between the two planes, or what's known as the true angle or the dehedral angle. So the true angle is the dehedral angle, alright? First, we need to find the true length of this line of intersection, right? So this line of intersection is what we found over here. So this is the line of intersection in plan, this is the line of intersection in elevation, right? So we're going to go parallel to that line of intersection, right? So I've already my two lines right across, which are 90 degrees, look. 90 degrees. And now I'm going to go parallel to that line. Sorry. Like so. And then we'll just simply then take our heights from our elevation, right? And that will give us the edge view of that, or the true length of it. Okay, so I'm just going to call them, let's say 1 and 2, or 2 and 1, whichever we want. 1 and 2. So there's a 1 up here, and there's 2 there. So like we've done before, we take the heights and elevation. And mark them off here. We'll call that 1. And 2 look is on the ground. So it'll stay on the ground here as well. Right, so we can just simply draw that, join that together then. That's the true length then of the line of intersection. Alright, true length of the line of intersection. Okay? Now, like we said before, if we look along the true length of intersection, so if we start up here and we look along that, okay, we'll see these 2 points as an edge view. If you can see them as an edge view, then lads, we'll be able to see our dehedral angle. Alright, so we're going to look at that now next. I'm going to pause that there now for a second. So you can see it here in our DCG solutions as well, look. Okay, so exactly what we've done here, just a different kind of a sketch, this one done here. Okay, so we found our lines of intersection, okay. We're in parallel to it then to see it as a true length. Okay, there's our true length. And then we want to look along it then to see it as a point view. Okay, and that gives us the point view then, look, of the point 2, 1 along this line here. So we're seeing that as 2, 1. Now as you can see here, look, it opens out like that and like that. Okay, so we need to kind of find that angle, right? Okay, so the way in which we do that, lads, is we kind of make a cutting plane across it. Okay, so you can see it there in the point 3, 4. All right, so I'm just going to show you there how that's done there now next, right? Okay, so if you watch on here, so okay, so I'm looking at this line here, so from a true length line. Okay, so I'm just going to draw another auxiliary off that. So I'm going to go at a right angle to it. I'm going to give us a plenty of space down here. All right, so along there somewhere. Like so. Okay. And now we can take our measurement of that back. So if you want to see 2, 1 and 1, 2, they're both on the same line. They're both along here. So 1. Come along here, so both going to be along the same line here. What distance? Take from the last view. So you can see the 2 is there. And you can see 1 is on the same line. So that gives us the point 1, 2. So now we're seeing this edge as a point view. Now we obviously need, if we're looking for the dehedral angle, alright, we're going to need 2 more points here to draw our angle, right? So the way in which we do that, lads, right, is we can take a cutting through our line of intersection, alright? The reason we're doing that is so we can see that our two spikes going over across and cutting the plane across it. Alright? So you can see it here again, look, right? So what they're doing, look, is taking a cut straight across here, look, right? Producing that kind of an angle there as well. Right, so that'll be able to see we're looking along this line here now. So I see the point 1, 2. Now looking along that 1, 2, seen as a point. So we're seeing the angle in between the green and the blue. Alright. So the angle in between there and there. Alright. So the way in which you do that then is bring it across, and you can pick that point anywhere you want. So you can pick it across here, you can bring it across here, wherever you want. Alright, and you just bring it over to your auxiliary. So we'll just do it here now, and that's our question almost completed. So again, I'm just going to take that and step by step towards the end. Right, sec is 0.34. Alright, so you can see that this one, 1, 2 is up above, 3, 4 is down below here. Okay, so then we're going to bring that line down. We're going to look at that now as well. So now we'll be able to see that as two edges. So 3, 4. So 3 and 4 are both along here somewhere. Where are they? Take it back. So there's 1 point. And there's my second point. We can simply join them up then, and that gives us our true angle or our dihedral angle. Extend that out. Right. Okay, so that's our angle inside there. Alright. So if you're looking at that there now, full screen. So what we did there, look, is first of all we found our line of intersection, okay? So we just extended our vertices, okay, brought it down and joined it up to one of the plan view. Same at the bottom, okay? Joined up our horizontal vertices, brought it up to the top and joined it up to the top here, okay? They both gave us our line of intersections. We said then if we wanted to find the angle of the dihedral angle, we must look along the true length of the line of intersection. So this is our line of intersection, but it wasn't the true length of it. So to get true length, just like we've done before, we conducted our horizontal or auxiliary view here. Right? We looked along that then to give us a point view. So looking in from here, we'll say. So we get a point view of the point 1, 2. Okay, like so. Now to get our angle here, we needed something to branch off of. Okay, so we said if we took a cutting across there, we'd be able to see the inside of the angle there. So the angle there between this one and this one here. Right, that's the line of intersection between the two planes. So we went right angle through it like that, onto our auxiliary, brought it down and took our heights. Like so. Alright. I just want to look at it here again. I said that they're pretty similar to that. Okay, so you can see where they brought the points across, brought them through, and brought them over. Alright. And I'm just going to finish that one off now with a few arrowheads, just to show exactly where my point is coming from. Alright. So that's your question there, so totality of it there, so I might just zoom out a little small bit there so you see a lot of it. Right, so what we found there now, lads, is we had two planes, one going this way, the other one going the other way, and both of those are intersecting, so maybe something like that might suffice. So two planes like that are both intersecting, like you can see in my little sketch over here, and we found a line of intersection. So line of intersection is from extended traces like so, right, then we got the true length of our line of intersection over here, We looked along it to find a point view, and then we just drew our points across here. Now, I normally just call it right angle straight through my right intersection here. A point on my red trace, point on my yellow trace, trace A and trace B, bring them across, bring them over, and take my heights back. Right, and that gives us the true inclination of our planes. Alright, so I might pause that there now, finish up that there. So